Okay, guys, today we are going to talk about big idea number 2, essential question number 1. So, big idea 1 was that atoms are the building blocks of matter. Big idea 2 is that the periodic table shows trends and properties of elements. So we're going to talk about how the periodic table was organized in order to give us even more information about the elements that are on it. Essential question 1 is how to identify properties and position of metals and nonmetals on the periodic table. So that's what we're going to talk about today. So if you look on the back of the periodic table I just gave you, you're going to see some notes that I've already written out for you. So just kind of want to follow along. If there's anything you want to add, please feel free to do that. Okay, so Aristotle said that all matter was made of air, water, fire, and earth, right? He was the one who discredited Democritus. Democritus said everything's made of atoms. Aristotle said no, it's not. That's what he thought everything was made out of. Scientists have identified 92 natural elements and created about 28 others. So of the ones on the periodic table, 92 of them occur naturally. Okay? Okay, so elements alone or in combination make up everything. Okay? Everything that you see, everything that exists is made up of the elements on the periodic table in some combination, okay? And from the video that we watched in the past 2 days, carbon is what really makes up life, right? Things that are living have a lot of carbon involved, okay? We've talked about the air, right? Our air being made of nitrogen, oxygen, and then a few other elements. We've talked about the combinations. We've talked about how you can have compounds, right, or mixtures. So all of these elements make up everything that we see. Okay, so a great deal of information about an element can be gathered from its position on the periodic table. So we've talked about what information we can get from each individual element based on its atomic number and its atomic mass. But its position on the periodic table also gives you a lot of information. So we're going to talk today about metals versus nonmetals, but tomorrow we're going to talk about groups or families and periods on the periodic table, and they give you even more information. Okay? All right, so on the front of your notes, you'll see a periodic table that is, I know it's a little bit hard to kind of tell the difference between the grays, because it's gray and not color. But if you take a look at the one on the board, you should be able to kind of see where the different colors should be. So everything on the left-hand side, including the lanthanides and actinides, everything on the left-hand side except for hydrogen. Hydrogen doesn't count in this, but everything else on the left-hand side is a metal. Okay? So if you want to, on your paper, if you want to draw in this line a little bit darker so you can see where the metals are separated from the metalloids, I would encourage you to do that. Okay, it goes right underneath boron, and then straight down silicon and germanium, I think. And then it's kind of like a step after that. So I would encourage you to kind of darken in that line just so you can kind of see exactly where that separation is.
It's already darkened.
Okay, well I just said if you can't see, if you couldn't see it well enough, you could darken it a little bit more. Okay, this middle section right here that separates your metals from your nonmetals are called metalloids. And then on the far right-hand side, starting with carbon and then stair-stepping down and then including the noble gases and then hydrogen. Okay, hydrogen's on the other side, but don't forget it. Those are all nonmetals. Okay, and we're going to talk about the properties of metals, nonmetals, and metalloids today. Okay, so here's just some picture representation of some of the metals that, and some of these you'll probably recognize: nickel, gold, copper. Those are metals that we know pretty well, right? This is rubidium. But there are a lot of things that are metals that you may not have thought were metals, okay? Like sodium, or potassium, or magnesium, or calcium. Those are all metals also. So just because they don't look like what we think of as metal, okay, doesn't mean they're not a metal. They're still metal on the periodic table. So we're going to talk about the properties of metals. And if you look at the back, on the back of your notes, you will notice, I wrote these out for you already. Metals are typically solids at room temperature, and they are very good conductors, which means they can pass easily heat and electricity. Okay, so very good conductors of heat and electricity. Metals have luster, which means they are shiny. You'll hear me use luster though versus using the word shiny, so you'll want to know what that one means. Metals have luster. Metals are ductile, which means they can be drawn into wire. So if you guys seen, like, if you go to the hardware store and they have like those reams of like metal, right? They're on like rolls, okay, like copper wire, things like that. Metals can be easily drawn into wire. They're also malleable, which means they can be hammered into sheets. How many of you have heard of the term sheet metal? Yeah, right? Sheet metal. So they can be hammered into sheets. This means malleable means they can be hammered into sheets. They have a very high melting point. So it's why we use metals for things that are like metals in cars or things that are going to be around high heat, because they have a very high melting point, so they can withstand a lot of heat. They are also very dense. Now remember we talked about density, seems way back, it wasn't that long ago, in Unit 1. Mass divided by volume, right? Which means it has a lot of atoms all packed together. They're very dense. Okay? A chemical property of metal is its reaction with water and oxygen. This causes corrosion and rust. So metals will rust and corrode when they are put into water or sat out in oxygen for long periods of time if they don't have some kind of a protective coat or something on them. Like, have you ever seen where if you have a car that's like a car accident and the paint chips off and then the metal rusts? Have you seen that happen? Once the paint is gone, the paint kind of acts as a barrier between water and air and all of those things. But cars are just made of metal, so if that paint starts to chip away, then the metal will rust. Okay, so let's talk about nonmetals now. These are just some examples: sulfur, nitrogen, selenium, bromine. They are found on the right side of the periodic table, on the other side of your metalloids along that zigzag. And then the only one that's way over here in family number 1 or group number 1 is hydrogen. Okay, so hydrogen is a nonmetal. Most nonmetals are gases at room temperature. Okay, where most metals are solids, most nonmetals are gases. They have a very low melting point and they are poor conductors of heat and electricity. So they're basically going to be opposite of everything we just said about metals. Nonmetals are going to be opposite of that. So where metals are good conductors, nonmetals are not good conductors. They also do not have any luster. They're typically very dull, not shiny. They are very brittle, so if you try to hammer them into sheets or make them into wire, they're just going to break. Okay, so this means nonmetals are not ductile, or this down here says not malleable. It's off the screen, but they're not malleable either, because they would just break if you tried to do that. They have a very low density, okay? Where metals have very high density, lots of atoms all packed really, really close together. Nonmetals typically do not. Now let's think about why that is. We're talking about gases versus solids, right?
Yeah.
Remember we talked about the particles of gases are typically farther apart, less dense, things like that. So that's why it makes sense that nonmetals would have a lower density versus metals that are typically solids. Okay? Now we're going to talk about metalloids. Now they're the group that's in the middle. And what's interesting about them is some of them have properties of metals, some of them have properties of nonmetals, and some of them have some of both. Okay? So these are just some examples: germanium, silicon, polonium, arsenic. And they are right along this zigzag line. Okay, stair-stepping. Metalloids, meaning metal-like, have properties of both metals and nonmetals. They can be shiny or dull. There are some that are, one or the other. They have some that are shiny, some that are dull. They can conduct heat and electricity, and it's better than nonmetals, but not as good as metals. Okay, so they're kind of in the middle when it comes to conductivity. They are typically malleable and ductile, so we're talking about they have that property of metals where they can be hammered into sheets, they can be made into wire. Okay. Anybody have any questions? On the back of those notes, you have all of that I just went over. It's all written down. Anybody have any questions?